Hi everyone, this is the video for lesson 4.4, proportions in triangles. So this is our last lesson for chapter 4, and our last thing dealing with finding and writing proportions from the lines and segments made in triangles. So we have a couple different theorems that we're going to talk about and then work on some examples. So our first is called the side splitter theorem, and that's because this line that's in the triangle splits those sides of the triangle. So the theorem says that if a line is parallel to one side of the triangle and intersects the other two sides, then it divides those sides proportionally. And we've seen triangles look like this a lot this chapter, where we have the little triangle inside the big triangle, and we can write proportions to find their sides, and we check to see if they were similar, and they are. So those pieces of the sides of that big triangle end up being split so that those pieces are proportional and they make a proportion. So the proportion is A over B is equal to C over D. So I know we've done some stuff with that parallel segment before, back in 2.4, I think. If we look at it like this, remember from 2.4, it was called a mid-segment. And we had some special facts about that, and one of them was that it was parallel to the bottom. But the special part here was that it went from midpoint to midpoint. Does this one go from midpoint to midpoint? Good. No, it doesn't. Okay, so that's why those pieces, A and B, are not equal, but they are proportional. So the corollary to that theorem, or the theorem that's can be made from the one that we just talked about, so they're very similar, is the corollary to the side splitter, and it tells us that if we have three parallel lines and they intersect two transversals, then those segments intercepted on the transversals are proportional. So the idea behind this one is pretty much just like the one that we had up there. The only difference is the transversals don't intersect at a point. They're going to intersect somewhere up here, but they're still splitting those parallel lines into a proportion. So our proportion would be A over B equals C over D. So the left pieces over each other equals the right pieces over each other. Okay, so our last theorem is the triangle angle bisector theorem, and this one says that if a ray or a segment or a line bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the original. So our proportion, again, is going to be A over B equals C over D. So this one is different than the other ones, and it's not making those similar triangles like what the other ones were doing, but the sides, this side to that bottom part, is still proportional to the other side to the other bottom. Okay, so let's see these theorems in action. So for all of these problems, we can write proportions to solve and find those missing variables and side lengths. So we're going to set up all of our proportions on the left side, and then you can go ahead and work out the proportions, the answers, and then we'll set up the proportions on the right, and you can work those out. So this is our first one, the side splitter theorem. We have a parallel segment to the bottom of the triangle. So we can see that this half is half of our proportion, and these are the other half. So we would have x over x plus 4 equals the other half, 12 over 18. There are a couple other ways you could have written it. You could have done x over 12 equals x plus 4 over 18, and you still would get the same answer. Remember how we talked about switching proportions around? I just wrote it this way because that's how the theorem defines it. Remember, when you cross multiply for that one, make sure you give it a hug before you multiply, and then you'll have to distribute. Okay, so if we take a look at the next one, this one's a little bit different because it's the corollary, but also they didn't give us this measurement. They kind of made it a little bit harder and told us how big the whole thing is and that this piece was x. So we know that this x piece and this piece together are going to make 11. So if I want to figure out how big this part is, we just have to take away the part. down here. So it would be 11 minus x. So we can set a proportion just like the top one. The top of the left over the bottom of the left equals the top of the right over the bottom of the right. So 9 over 4 equals 11 minus x over x. And again, when you solve it, remember to give it a hug. So the bottom one is using our triangle angle bisector theorem. So we can do the same thing, left over left equals right over right. So 10 over 12 equals 18 over x. So moving on. This one up here, I know it looks more complicated, but the proportion writing is exactly the same. Okay, we got x minus 1 over x plus 3 equals x minus 1 over x minus 6. So for this one, remember your algebra skills. You're going to have to give everything parentheses before you cross multiply. And then when we cross multiply those, we would have x minus 1 times x minus 6 equals x minus 1 times x plus 3. If you know what to do next, pause your video. So remember, when we have two parentheses next to each other, we have to distribute. So that would mean we would do x times x times negative 6, negative 1 times x, and negative 1 times negative 6. Same thing over here. And then after that, we just have to combine like terms. So combine like terms on the same side first. And then combine like terms across. So for here, on this one, we actually luck out a lot, because when we subtract those x squared minus x squared cancels out. So we just have a regular equation now. Negative 7x plus 6 equals 2x minus 3. And you can solve that using inverse operations. Okay, so go ahead and pause your video. Try to set up your other proportions and solve the ones that we made already on the left side and find x. Be careful on this one. We have two variables, so you're going to need to set up two proportions. What I would do is cover up one line, write your proportion for x, and then cover up the x line, write your proportion for y. Okay, go ahead and pause and get all those done, and when you come back, I'll show you the answers. Okay, welcome back. Here we have our proportion solved for all of them. If you're finding it hard to see, remember I scanned the notes and they're on the website, so you can go and look at them and make them a lot bigger. So I'll just go over the proportions that I wrote for the ones that we didn't do together, and then if you have any questions, you can ask me in class. So for the second one on the right side, remember I said to cover up that y line, and now you can see x over 30 equals 15 over 26. And then if we cover up the x line, we have 15 over 26 equals 16.5 over y. So remember, this was the corollary to the side splitter, and this one is a little bit different than the one on the right side because it's turned and the parallel lines are going up and down instead of horizontal. But the proportion comes out to be the same. This one, left side over the right side, so x over x plus 1 equals 5 over 6. So if you have any questions, make sure you write them down so you can ask me in class tomorrow. Werner out.